Hello. In this knowledge clip, we are going to discuss elasticities. Elasticity is a key measure used by economists to describe the sign and the strength of relationship between two economic variables. In microeconomics, the most important elasticity we are going to use will be the price elasticity for demand. This can, well, I'm going to at least denote it like this. And this will be nothing else than the ratio of two relative changes. The first is the change in the relative change, or a growth rate, if you like, or just a percentage change of the quantity demanded. So absolute change divided by the level, some initial level of Q is going to give you simply a relative change divided by a relative change in price. So this is going to be a measurement unit-less quantity, a dimensionless quantity, which is going to simply tell you that if price goes up by 1%, then the quantity demanded is going to change by epsilon percentage. So if price goes up by 1%, then the quantity is also going to go up by epsilon percent. But of course, this epsilon could be a negative number, and in case of quantity demanded, of course, this is going to be a negative number, so it's going to be less than 0. Why do we use elasticities? The most important reason is perhaps comparability. So if you have just the absolute changes, so only delta Q and delta P, then these quantities, you can write it up, Q2 minus Q1 and P2 minus P1, are all going to have a certain measurement unit. For example, Q could be measured by kilograms or pounds, and P could be measured by euros or pounds or dollar. So altogether, when you just look at absolute changes, then you still retain the measurement units. And so if you have something like minus 40 kilograms per euro and minus 100 pound per dollar, well, these are not really comparable quantities. On the other hand, if instead you use relative changes, so for example delta Q divided by Q1, then you will have a dimensionless quantity. Yeah, because here you have, for example, kilogram, but here also you have kilogram. So actually you are going to divide by the same measurement unit. And finally, you are just going to get simply a number. For example, 0.4 is going to be a 40% increase. There is another reason as well, namely that elasticities can tell you a lot of information about the effect of a change in price on, for example, total revenue. But this is well described all in the lecture slides and also in the book. And here, I would rather like to focus on certain technical issues. So, how would you calculate the elasticity of demand, or let's call it by its full name, price elasticity of demand, so in the situation when you only know two particular points of the demand curve. So, in this first case, we do not have a knowledge of the whole demand curve. All we know is that at a certain price, a certain quantity is demanded. So let's assume that when we have €2 price for bananas, then 60 kilogram is demanded. But if the price is €1, then 100 units will be demanded. So in this case, you should use a discrete formula. So possibly the easiest would be to do the following, but this will be wrong, okay? So I'm already telling you that I'm showing you something which you shouldn't do, but it's easy to understand, and later I will explain why this is a problematic approach. So let's assume then that initially the price was €1. And that means that we have here 100 kilograms as quantity demanded, and here we have a higher price. So we start with a low price and we arrive at a higher price, so the initial situation will be number 1, P1 and Q1, and the final situation is going to be P2 and Q2. That is, we are looking at this change. Now, in this case, for the elasticity, price elasticity of demand, we should calculate first the relative change in Q. Now, that would be then Q2 minus Q1 divided by the initial value, which is Q1. And this whole stuff, this is also divided by P2 minus P1 over P1, which is the relative change in price. Doing this is going to give you an elasticity for the case when the price doubles. Let's see, Q2 minus Q1 is minus 40. This is divided by Q1, which is 100. This is divided by the relative change in price. The relative change in price is 2 minus €1 divided by the initial price, which was €1. So here we are going to have minus 0.4 divided by 1, or just simply minus 0.4. So if we look at this particular situation and the price increases from 1 to €2, then we find that the price elasticity of demand of bananas was minus 0.4. That is, if price goes up, quantity demanded must reduce, and this is in line with the law of demand, of course. And we also find that the demand for bananas is inelastic, because in absolute value, this minus 0.4 is just 0.4, so less than 1. So it must be an inelastic demand. Because we are talking about points along the same demand function, if we had a different situation and actually we were observing a reduction in price instead, then consistency would require that we calculate the same elasticity. Let's try if this is the case. So now the initial situation is going to be Q2 and P2, not Q1 and P1. In this case, here I'm going to use a different color. We are going to have, first of all, the change in Q is going to be 40, because we started with 60 kilograms and we went up to 100 kilograms, divided by the initial quantity, which is now 60 and not 100. So you can see now the difference between this one and this one. And this is divided by the change in price, which it was then actually there was a reduction in price. So here we have minus 1 over 2 because the initial price this time was 2 euros. So we have here in the numerator 2/3, which is divided by minus half. And that's going to give you minus 4/3 or minus 1.33 as elasticity of demand. We didn't get the same number. There is some inconsistency here. And also, our main conclusion is different because, as you can see, no, we have an elastic demand for bananas, and both cannot be true. So, what is the reason for this? The reason for this is that we used different initial values to calculate the relative change. So, here in the first case, the change, which was basically the same in both formulas, just sometimes you got the minus in the numerator, sometimes in the denominator, but the point is that here you had the same absolute change, but in this particular, so in the first case, the minus 40 was divided by 100, and here 40 is divided by 60. Also, in case of price, first the initial price is 1, and in the second case, initial price is 2. So obviously, these values cannot be the same. For this reason, we are going to use a different formula called the midpoint formula for elasticity, which is going to prevent this inconsistency. So, instead of using a different initial value for the case when price is reducing or price is increasing, we are going to use the same initial value, which is going to be simply just the average of the initial and the final value of the quantity. That means that the midpoint formula is going to look like this. So first, we are going to look at the numerator. The numerator is going to be Q2 minus Q1. Doesn't really matter. It could be Q1 minus Q2 as well if in the denominator you use P1 minus P2. So this is going to be divided by Q1 plus Q2 divided by 2, which is just simply the average. And the very same can be used here as well, but of course this time for the price. Here you go. This is going to work very well, and this is going to be the same because if you for the other direction, because Q1 minus Q2 divided by Q1 plus Q2 over 2 and P1 minus P2 divided by P1 plus P2 over 2 is going to be exactly the same. Why? Actually, because this one here could be written minus Q2 minus Q1 over Q1 plus Q2 over 2. And this here could be written as minus P2 minus P1 over P1 plus P2 over 2, so the average price. And that is, you can see minus divided by minus is just plus 1. So you can see that this one must be the same as this one. Try to figure this out at home. So if this is true, then we should be able to find a correct elasticity estimate for this particular case for bananas. And we can do so. So first of all, it doesn't really matter which situation we take as initial and final. Let's see. First of all, we know that the let's see then the price increase version. So the Q2 minus Q1 must be 60 minus 100 kilogram. Okay, I'm not going to write units anymore. Usually we don't do that. And this should be divided by Q1, which is 100, plus Q2, which is 60. So 160 divided by 2, that's 80. And here we know that here we have 2 minus 1 divided by the average of 2 and 1, which is just 1.5. So if we do this, then actually we have here minus 40 over 80 divided by 1 over 1.5. No, the minus 40 over 80 is actually minus 1 over 2, and this can be then multiplied by 1.5 or by 3 over 2, which is 1.5, and then we have here minus 3 over 4 or minus 0.75. And you can see that if you were looking at a price reduction case, you would get exactly this. That is the reason I'm going to ask you that you use the midpoint formula in the future.